Now, the next thing we're going to talk about is key lookups and cardinality estimation. We're going to go back to our black index here, but I'm going to add a couple of fields to the query. I'm going to say select ID, display name, and age. But if you look at the black pieces of paper, display name and age aren't on there. So there are two ways that we could execute this query. One way that I could execute the query is I could still use this. I could go seek directly to July the 1st of 2014. I could go grab my handy scratch paper, write down the IDs and last access dates of the rows that match. Then I could go look up their display name and what was the other thing I asked for? Age. Display name and age over on the clustered index. Now, sometimes SQL Server does that. In this example here, that's exactly what we're doing. Now notice this is the first time we have kind of a two-dimensional plan. Instead of just going right to left, we also go top to bottom. So at the top right, the first thing that SQL Server chose to do was seek directly into 7/1 of 2014 on our index. It made a list of the rows that matched and looked up each one of them by their key over on the clustered index. Now's the time to tell you that I lied a little bit. When you and I built this index, I said the index creation statement would be create index last access date and ID. But I don't have to put ID in the index because SQL Server always adds it for me. SQL Server, for every row that it finds over here, has to be able to join to the matching row over here so that it can do a key lookup, because you wouldn't want to find somebody's last access date here and then go, all right, well, where are they? I have no idea how to find them over here. So the ID, because it's the clustering key of the table, is always included in all my non-clustered indexes. There's not an extra overhead depending on how you configure it, although there can be if you're doing things like playing around with uniqueness. We're going to leave that for fundamentals of index tuning, a class that we have later. When you're looking at an execution plan like this, the two-dimensional with an index seek immediately followed by a key lookup, what you want to do is you want to hover your mouse over the key lookup, and SQL Server will tell you what the output list is. This is the list of extra fields that it had to go back to the clustered index in order to get. And this is where it becomes a little bit of an opinion-based thing. If they're small, and if you use the fields a lot, notice I got air quotes going on around me. If these fields are small and you use the fields a lot, then it might make sense to add them to the index itself. Brent, what does small mean? Yes. What does a lot mean when you say use them a lot? Yes. This is where it starts to become a whole lot of a gray area. I'll tell you that I probably wouldn't want to put varchar max fields in here because it's going to be huge and ginormous and bloat the size of my index. But I might be okay with smaller ones like display name and age if I genuinely need them all the time and if they save me a ton on my query plan. The designing of all of that is something we go into in our other classes. But in order to get that picture for you, in order to show you that index seek plus a key lookup, I had to cheat. Those of you who are fully caffeinated probably noticed that the date wasn't quite right and the estimates were a little unusual. Because when I use the date we've been using so far, July the 1st of 2014, well, a lot of people have accessed Stack Overflow since July of 2014. So SQL Server chooses a totally different execution plan. SQL Server says, I don't have time to do this index seek plus writing a bunch of rows down plus looking up every row that match. Because notice a lot of rows match, 148,000 rows match because a lot of people have logged into Stack Overflow since then. There's a tipping point with indexes where if SQL Server thinks it's going to do a whole bunch of index seek plus key lookups, that it has to make a decision on when it should use the index versus when it should do a clustered index scan. And the cool part about this is that it has to make this decision before it reads the table. It's not allowed to go read the table and then change its mind. It's not allowed to scan some of the data and then go, oh, you know what? I'm better off with a clustered index scan again here. Oracle does. Excuse me. Sorry about that. So what SQL Server does is it has these statistics. For every index that I create, in the case of IX last access date ID, we get a statistic with a matching name. We don't have to lift a finger. This happens completely automatically. And a statistic is one 8K page worth of metadata about what's inside the index. Even if you suck at performance tuning, you suck at database administration, and you never create an index, SQL Server will go off behind you and create its own statistics. It's like, I always think of SQL Server as a guy because he's dumb and he's stubborn and he refuses to ask for directions. Trust me, I got this, even though he doesn't usually got this. I say he's stupid, but he's lovable. I love him. He's probably smarter than I am, but he comes off as kind of dumb. Here, I've been repeatedly querying on the 5th field of the table and the 8th field of the table. So the nice folks in Washington decided to create a system-created statistic on the 5th field and the 8th field of the table, one of which happens to be last access date. So what a statistic is it's one 8K page worth of metadata about the stuff that's inside your index. It helps SQL Server understand how many rows are involved in it, what those rows look like, and it has a sampling of some of the rows so that SQL Server can predict what it's going to find when it pops open this query, or when it starts executing the query for results. And I'm going to show you a command that, I tell you what, I don't ever run this in production. It's not that it's dangerous, it's just that it's not usually that terribly useful. But knowing that it exists will start to shape how you think about execution plans. DBCC show statistics. Now, usually when you see a command with DBCC in the front, it's not safe to run. This is totally fine to run in production. You'll get the same results in development as long as you have the same data over in development. But if you have a different set of data, you're not going to see the same statistics. Pass in the table that you want to analyze and the index that you want to analyze. It's not doing any new analysis work. It's simply reading from the 8K page of statistics and dumping out the results. Puts out 3 set of results. First set says the stat was last updated on January 23rd. At the time, there were about 300,000 rows in the table. I sampled all 300,000 rows of them. SQL Server is exactly like a political pollster. The larger your population becomes, the more it results to sampling, just taking samples of the audience to figure out how everybody's going to vote. Just like political pollsters, sometimes it's right, sometimes it's hilariously wrong, or terrifyingly wrong, depending on how your leanings go. That statistic is on these 2 columns. It's on first, last access date, then ID. And then here's the histogram. Now, histogram sounds really terrifying. It's just a bunch of buckets. The first bucket is for people with a last access date of August the 1st, 2008. There is exactly 1 row with a last access date equal to that. Probably Jeff Atwood coding in the middle of the night by himself. Then, in the range between August the 1st, 2008 and November the 27th of the same year, there are 1,222 rows in that range. Exactly 1 row is equal to that last access date. And out of that 1,222, all of them have different values for last access date. Well, of course they do, because it's last access date on a website. It's not like everybody logged in at exactly the same time. That would be pretty much impossible. You'll notice, as you look down the histogram, the date buckets aren't the same size. Some of them are weeks, some of them are months, some of them span more than a year. You'll also notice that they're not all the same size in terms of population either. We got 1 bucket with 1,000 rows, 1 bucket with 5,000 rows here. That's because SQL Server has to paint the best picture that it can inside 1 8K page. And unfortunately, that means you only get 201 buckets for your histogram. You only get 201 steps max, which doesn't work out very well as your data really starts to grow. When you start to get into big data, then it really starts to become troublesome. So this is what SQL Server uses when we pass in, show me all of the users where last access date is greater than August the 1st or July the 1st of 2014. SQL Server says, well, I'm going to scroll down through this histogram, and starting at about row 56, I got some of the rows from this bucket belong. Notice that I don't have a bucket for exactly July the 1st of 2014. I got a bucket here that has an entire year in it. And I know that some of the users in this range will match. I'm not sure exactly how many. I'm going to have to do some statistical math here. And then I'm going to scroll down through the rest of the buckets, going add it up, figuring out how many rows I'm going to have in total. So this is where, when you're hovering your mouse over stuff in the execution plan, that the estimated number of rows comes back. So for example, here, where I'm saying where last access date is greater than July the 1st of 2014, SQL Server added up and went to 148,408 rows. I have horrible taste in music, truly epically bad. So then the actual number of rows is pretty doggone close. That's actually pretty awesome. When SQL Server is able to understand what you're passing in, you don't have any fancy pants functions inside there. It does a really good job of guessing how many rows it'll come back. But the more mysterious you get with the T-SQL, the harder it is for it to estimate accurately. Here's a couple of other examples of different kinds of stats, just so that you can see one that's on a varchar field and then one that's on an integer field. And when you're trying to get the most accurate query plans possible, there are two things that you can do to help. One is that you can keep your statistics up to date. SQL Server automatically updates your stats whenever about 20% of the contents of the table have changed. That's even a huge stretch. There's this row mod counter that tracks the number of times you've changed the table, and it's just ticking up continuously with each insert, update, and delete you do. It's not perfectly accurate. There are some interesting problems with triggers. It's much better off if you go through and update them proactively on your own. I'm a huge fan of Ola Hollengren scripts. He's an MVP out of Sweden or Norway. I always forget Finland, one of those countries. I'm going to stop there immediately. I love those countries. They're amazing. They're really cool. Now, weather I'm not so fond of, but okay, that's cool. Really powerful stuff, has all kinds of really cool options. The other thing that you can do to help is that you can figure out how to write better T-SQL to make it easier for SQL Server to interpret what you're trying to do. And I'm going to give you a really simple example. These two queries produce exactly the same results. I've taken the same where clause that we've been using so far, but now I'm picking a specific day. I'm saying, SQL Server, go find me all of the users who accessed the system on August the 27th of 2018. Both of these queries accomplish the same goals and return the same number of results, but they get completely different query plans. The top one says, I'm going to do a clustered index scan because I estimate that 2,076 rows will come back. Because SQL Server was able to match up these dates with what's in your histogram. SQL Server goes, oh, yeah. I know when this day starts. I know when this day starts. I can look up these buckets in the histogram, and I'm good. But when I look at the bottom one, SQL Server's like, I have no idea what this could possibly equal out to. I can't comprehend what the first time for August the 27th would be and what the last time would be. There's no way anyone could know. That's not really what he says. You know what the funny part is? If you look down in the execution plan, he goes to figure out what the first day would be, what the first date time would be, and he knows that he can seek in on the index. But hey, SQL Server, how many rows do you think are going to match? 2. So, SQL Server, where did you get that estimate from? I made it up. Hey, listen, you put the function in the where clause, man. I don't have time to go crack open that complex T-SQL and figure out what the first and last time would be. So I just gave you an estimate of 2. See, when SQL Server has to make these decisions between when it should do a clustered index scan versus when it should do a key lookup, it's really important that you write the most accurate, easy to interpret T-SQL as possible. There's a huge difference between T-SQL that compiles and T-SQL that scales. There are things that Microsoft ships to check the box. Hey, those $47,000 core people, they have table variables. We need table variables. And they'll ship a feature even though it doesn't perform all that well. Because a lot of us, when we're looking at what should we buy, we just go, well, SQL Server checks all these boxes. It seems to have everything that Oracle has. It's just as good, right? Let's go with this one. And honestly, for the most part, I adore SQL Server. It's wonderful. It's fantastic. And it does all kinds of really cool stuff. But you just got to watch the feature list, that sometimes it's just that the box is checked. It's not that the feature is really all that fast. Now, there are a couple of ways that we could fix this here. One is that we could rewrite our T-SQL, but the other way is that we could just give SQL Server a slightly different index. We could give it a covering index that covers the query we're trying to accomplish here. If we're constantly trying to bring back display name and age, well, we could just include display name and age inside this index. This is where the next piece of paper in your handouts comes in, the gray piece of paper. Now, if you notice the gray piece of paper, which is up on screen here, it results from either of these two index creation statements. The top one says, I would like my user sorted by last access date, ID, then display name, then age. The second one says, I would like them sorted by last access date and ID, but then just include display name and age. I don't know where this is coming out, but there's this myth out there that includes are magically delicious, like that they're the vaping of the SQL Server world. Oh, it's totally healthy. There's nothing wrong with includes. I can have as many of them as I want, and I can quit at any time. No, they take up the same amount of space on these leaf pages. The exact same space. The same space on the leaf pages that they would have taken as if they were in the key. Well, but when it's just in the includes, I don't have to worry about sorting them. BS! Look again. Say that the person up at the top right, Sarcastic up here, say that Sarcastic has a birthday, and he goes from 30 to 31. We issue an update statement in the back end, and we change his name from 30 to 31. Now, the include people in the crowd are going, yeah, see, check this out. If my index is the bottom one, here's how the update happens. We're going to read that page up off of disk. We're going to change his age on the page. Then we're going to write it back down to disk. But I don't have to move him at all. It's great. He stays in exactly the same place. All right, Sherlock. Look at the top index. Let's say that he's sorted by all four of these fields. Oh, yeah, it's so much worse then. I'm going to have to move Sarcastic around on the page. Where? If we change his age from 30 to 31, point on the monitor where the bad man touched you. Point on the monitor where you're going to move Sarcastic's row to. There's a trick. What if we change his age? What if we change his name? What if we change him from sarcastic to optimistic? Does that change where he lands? What if we even change his ID? Does that change where he lands? When your first field in an index is very selective, the sorting of the subsequent fields isn't as impactful as you think. When the first field is something very binary, like is active, yes or no, then the sorting of subsequent fields matters a lot. But here, last access date really determines where the rows land. And it doesn't make a rip of difference whether these fields are included or in the key. The real problem is when you index on a field like last access date, what happens every time someone lands on Stack Overflow? What happens on whenever somebody opens a page? We're going to pick their row up and we're going to move them to the end of the index. Because until Doc Brown logs in his DeLorean, no one's ever going to log in the past in SQL Server. So we're going to keep picking up these rows and putting them on the tail end of the index. That first field is going to be very hot. It's going to change all of the time. In a perfect world, I don't lead my indexes with fields that are very hot, but there's nothing built into SQL Server that tells you whether a field is hot or not. It's up to you to figure out which ones are hot or not and designing your indexes appropriately. But let's say that I run the daylights out of this query. I really need to index it because I just run this query constantly 24/7. I build the covering index for it, and it doesn't matter whether I put those display name and age in the key or in the includes. It has the same effect on this query plan. Let's take our query plan, select ID, display name and age, where last access date is greater than 7/1 of 2014, order by last access date. Now we've collapsed it right back down to a single operator. We don't have to deal with this index seek plus a key lookup again. And now suddenly the estimates on the number of rows, they don't matter as much because we're going to do the same plan regardless of how many rows come out of this. So what we've learned so far now, an index seek plus a key lookup means that we may need wider indexes. It's not that key lookups are always bad. They can be completely fine in small quantities. What does that small quantity mean? Depends on the workload that's involved in your server. The more of these you're having to do, the more it may become a performance problem for you. Statistics are the objects that help SQL Server understand which objects it's going to pick, which indexes it's going to do a seek from, which indexes it's going to do a scan from, and in which order. It's hard for SQL Server to take your T-SQL and perfectly interpret it to guess exactly how many rows are going to come back, and especially it only gets worse as we start to join in multiple tables inside there. So now your next steps as to what you do next if you go over to our site and go to brentozar.com/go/engine, I've got more how to think like the engine videos up there already too, where I talk about how this impacts hardware, how it impacts sorting, all kinds of good stuff. And that's all totally free. Then your next stuff after that is to hit our fundamentals of index tuning. It's a one-day class where I go through and give you demos in the Stack Overflow 2010 database, and I give you problems that you have to solve as I do the lectures. After each lecture, you get a series of indexing problems to solve. Then you get to watch me solve those same things. You do fundamentals of index tuning on your desktop. That keeps the costs really low, and the Stack Overflow database is small. But when it's time for our mastering index tuning class, which is the next level up after that, you get a VM up in the cloud with the full-size Stack Overflow databases, 300 plus gigs at the moment, and much harder indexing problems. And because, of course, not everyone can just spin up a big monster 8-core, 60 gig of RAM VM, I give you those up in our cloud provider so that then you can go do the slicing and dicing work up there. More info about all that stuff, plus the slide decks for this, recorded copies of this, the handouts are all up at brentozar.com/go/engine.